Today I'd like to look at a couple of mixture problems. Uh, we want to set up an easy way of finding solutions to these mixture problems using the information that we've been given. And we want to first identify what we have, what we're adding to it, and what we desire to get. Those are the three things that I always look at when I look at a mixture problem. What do we know? What are we given? What are we adding to it? And finally, what is the desired outcome? And then from those three pieces of information, we're going to set up an equation. So, what do we know from reading this problem? Well, we know that we are being asked how many liters of 20% solution should be mixed with 30 liters of a 50% solution to get a mixture that is 30% acid. So that's our problem. We know this piece of information right here. We know that we have 30 liters of 50% solution. So under the know, we're going to put that. 30 liters, that is 50% acid. And what are we adding to it? Well, the adding to it is this 20% right here. Okay, so we're adding to it a 20% solution, but we don't know how much. We just know it's in terms of liters. So we'll call it x. So we might define a variable. Let x equal the number of liters of acid solution. And our desired outcome is to get a solution to get so many liters, and I'm going to change colors real quick, so many liters of 30% acid. Now, let's start setting up our equation. So to set up our equation, we want to put these things together in the form of an equation. So we start with, what do we know? We know we have 30 liters. That is 50% acid. So it's always going to be set up as the number of liters times the concentration as a decimal. So number of liters times concentration as a decimal. So 30 times 0.5 plus we are adding a 20% solution. So 0.2 times, we don't know how much we're adding, but when we're all finished, this has to give us our desired outcome, which we don't know how many liters that is, but we know it's 30% solution. So 0.30. And I could have put a 0 in there just so that those match up. Okay? So again, converting our percentages to decimals, we just simply move our exponent 2 places to the left. Now, inside our parentheses here on the right, we've got to account for the amount, the quantity of liters that we had. Well, we started with 30 liters, and we added to that some unknown amount. So inside our parentheses is always the number of liters we started with plus the unknown amount. And now we just solve this equation. So we're going to find the product here of 30 times 0.5. That would be 15. Plus, we're going to simplify that just to be 0.2x. And then we're going to distribute on the right hand side to remove our parentheses. So 0.30 times 30 would be 9 plus 0.3x if we distribute. Now, notice we have variables on both sides, so we want to collect them to the same side. And I always like to collect them so that the variable has a positive coefficient. So in other words, the number in front of it stays positive. Well, this 0.3 is bigger than this 0.2. So we're going to subtract 0.2 from both sides. 0.2x, that is. And at the same time, we're going to move all the constants to the other side. So we had a 15 over here, and we're going to subtract 9. And now we just clean up that step. 15 minus 9 is 6. So we have 6 is equal to 0.1x. We're cleaning up on the right-hand side. We can think of this as being 30 cents minus 20 cents. So 0.3 minus 0.2 is 0.1. And then finally, we divide by the 0.1 because we're undoing this multiplication by 0.1. So we divide, and 6 divided by 0.1 will give us 60. So we record our final answer as 60 liters of the 20% solution. Okay. Next, I want to take a look at another type of problem, very similar to this one. In this particular problem, we have a cleaning company that has 20 gallons of bleach, and they want to mix it with some water to create a solution that is only 10% bleach. So they're diluting it. The term is to dilute. That just simply means to make its concentration less. And we do that typically by adding water. Okay, so in this case, we want to think about our percentages in that sense. So what do we know, or what do we have? Well, we know that we have 20 gallons of bleach. So it's pure. That means it doesn't have anything else mixed with it. It's just the chemical compound bleach. Okay, what are we adding to it? Well, we're adding an unknown number of gallons of water. Now, the question is, what percent of that water contains bleach? Well, for those of us that drink water, we certainly hope that it's 0% bleach. We don't want any bleach in our water. Chlorine's okay. That helps purify the water, but no bleach. Bleach would not be good for us to drink. All right, and finally, what is our desired outcome? What do we wish to have? Well, we wish to have a cleaning solution that is, we don't know how many gallons it'll be, but we want it to be 10% bleach. So now we can set up our equation. Our equation is, what do we have? We have 20 gallons of a pure bleach. Pure bleach would be represented by 100% pure, or the number 1 as a decimal. We're adding to that some unknown number of gallons that doesn't have any bleach in it. That would be 0x. And when we're done, we want a concentration that is 10% bleach. And remember, on our right hand side, it's always the percent solution times the quantity we have. So in this case, we'll have 20 gallons of bleach mixed with some unknown number of gallons of water, and that will create our desired result. Okay, and then we're going to solve our equation here. So we have 20 times 1, or 20. This would become 0, is equal to, we're distributing on the right, so we would have 2 plus 0.1x. Then we subtract 2 from both sides, so we'll get 18 is equal to 0.1. I left out my x up here, my apologies. 0.1x. And then finally, we'll divide both sides by 0.1, and we'll get 18 over 0.1, which is 180. So we write our final solution, we're going to have 180, or we're going to need to add 180 gallons of water to be able to dilute all of that pure bleach down to a cleaning mixture that is 10% bleach. Okay? Here's a couple of problems for you to try on your own. I'll post the solutions in the descriptions below. Good luck to you.